This is my screencast for CA3 of the Programming Principles module, and this is the shooter game, first person shooter game. So to start off, I'm going to quickly jump into the game and show you how it plays. I'll do a quick playthrough and then I will break down the code. So as you can see, I have enemies, got pickups, such as this one here, chicken pickup. I have walking enemies that when they get within a certain range they'll shoot me. My health goes down. You can see there, I can shoot them and they'll die. I've got stationary enemies, which if I do a body shot, they lose 20% of their health. If I do a headshot, they die in one hit. So if I do a headshot up here, you can see headshot, one hit. I've got 3D spatialized audio. I've done a script for vehicles moving at different speeds along these hover highways. I've used the same script for movement to do these kind of like little alien rats that run on a loop. If you shoot the rat, which I can't do because I'm very bad at aiming, but you'll get an optional achievement. As you explore the level, there's enemies you need to shoot, and if you run out of ammunition, which I will do now, so you can see the ammo count is dropping. I'm going to go down. So I'm now out of ammo. I cannot shoot, but I can pick up more ammo. So I now have more ammo, and we've another enemy. I'm going to shoot. Go. So as it says, main objective, steal back the boss's retro elite speeder. So looking to get his car back. So we're going to work our way down. We also have steal the key to the warehouse from the bar. So this is the bar. There's the floating key. We'll come around. I've picked up the key. You can see steal the key to the warehouse is now highlighted. Oh, got more enemies coming in. There we go. Got some more of the enemies. Some more pickups. Oh. Then if I can get in here, you can hear the sound effect of us unlocking the door, and it opened, and we can go in, we can grab the key, and we win. Mission success. Then very quickly I'm going to show what happens if you fail a mission. So we'll go back to the menu. Here's the main menu. It's giving you a message, a bit of story setup, and we can hit proceed to start the mission. I'm going to go in. I'm going to let myself die deliberately, so I'm just going to aggro all these enemies. Gonna come up here and just let them shoot me, and you can see the health drop down. So I'm being shot, I'm being hit, I'm letting this happen. Health is dropping down, and I died. I became scrap metal and it says mission failed. So that's my different win-lose states. Okay, so a lot going on there, so I'm going to quickly jump into it and explain what's happening. So firstly, I'm going to jump into my main level, which, as you can see, I've made out of an asset pack that I actually purchased from the asset store. This asset pack is called the Polygon Sci-Fi City asset pack, and this has quite a lot of nice assets that I was able to build my level out of. You know, all of these pieces, the barricades, the vehicles, as well as my enemy robots. I was able to use the 3D models and animate them using the website Mixamo for their animations. You can also see I utilized different colored lights in the scene just to kind of give it this kind of retro future look, very cybernetic kind of look. Next thing I'll focus in on is my scripting code. So the first thing I want to show is the main playable character. So on the gun, if I go into the player and go into the prefab, open the prefab. So the player has a couple of interesting things. As you can see there, some of the UI is kind of in 3D world space away from the user's the camera, which is embedded into the controller. Some more of the UI is attached to the gun. The ammo and health is on the gun, so when you look at the gun you can see it. What was I going to show here? Yeah, so this player is using the Unity Standard Assets first person controller for movement, and then on top of that I have a player script which I will show you now. Player script. So this player script here, it's taken originally from one uploaded to Moodle and modified from there, and I've added a couple of things to fit the brief. So firstly, I've added an audio source, and this audio source lets me play the one-shot sounds of the different pickups, sound effect pickups. So when you go to pick up ammo, health, or the key card, it'll play the pickup sound effect that's attached to that pickup. I'll show you the pickups in a second. But you can see here on trigger enter, I've set up this switch case which goes through the different types of objects that I can use. So I've set up different tags for my prefabbed ammo pickup, my prefab health pickup, key pickup, door, and finally my level end prefab. And so the idea is if the player collides with one of these objects with a tag of this, then we assume if it's ammo, then we can grab the ammo component, and from that grab the ammo value and increase the amount of ammo we have. We play the sound effect and then we execute the pickup. And this here, if I jump into it, you can see here will just destroy the pickup, so it'll remove it from play. So pickups in the game, what I've done is I've created this parent pickup class which my different pickups inherit from. This pickup class actually animates the objects, which is another requirement in the brief. I have a rotate and I've a positional hover effect going on here. I also have some UI that appears on the different pickup, and if the pickup UI is set, this canvas, I set it that it'll always look at the player. So no matter where the user is looking at, the UI, which tells you how much of the ammo is giving you, or how much health the health is giving you, it'll always be positioned facing the player. Yeah, so then what inherits from this is ammo pickup, which just sets a variable called ammo, which we can give a value, which we initialize here as 12. Health, similar, we set health. Key pickup is interesting. We actually attach a door, and I'll explain how the door works in a second. And then the only other thing that the player walks into other than the door is the level end, which didn't need its own script. I just attached to the 3D model, I attached the tag level end, and it had a box collider. All these have box colliders in their prefabs, and I'll show them in a minute. So next thing I'll show quickly is my door, and this kind of feeds into the key pickup, which was another requirement. We needed a door that could be unlocked with a key. So in the game, and I'll go back to Unity for a second to show you, in the game I've got actually two doors in my scene, and they both use the door script. So this is one of the doors here, if I can select it, door trigger. So the door trigger here uses my door script. It takes in a top of the door and the bottom of the door. Now I did this because in this style of game, we've got these sliding doors. We've got a base which can slide down, and a top which we want to slide up. And so my script basically takes in a top and a bottom. It assumes its initial position is closed. It sets an offset vector for position, a vector tree for position for both of them, which we assume is the open position, and the speed it takes to open and close. I have a boolean to determine is this door locked or not, and I have booleans which determine if the door is in the process of opening. I'll explain that. And I have a sound effect for the door opening, the door closing, and the door unlocking. The sound effects in this game I've sourced from Freesound and did some minor adjustments using Audacity to change the sounds. Okay, so I'll show the door script real quick. Yeah, so the door script, fairly straightforward. initialize my variables in my start, I'm getting the start position, the close position for both the top and the bottom by assuming the initial position. I said that earlier. And then the open position for both of them is the close position plus their offset, if that makes sense. And I'm initializing the audio, I'm grabbing the audio source off the door object. In my update, I'm checking if the door is not locked and if the door opening boolean is on, then we're going to do a lerp of the position for both of the doors. This will lerp between the two positions, open and closed. We're increasing this fraction value by the time since last frame multiplied by the speed we want to travel at. And so this fraction will go from 0 to 1 in the length of time that we set our speed to be, and this will lerp at that speed. So that's how this works. So this is if the door is opening, it will do this. Once the door is finished opening, we set this boolean back to false and we set the fraction back to 0. If the door is closing, it does the exact same thing but the other way around. So we go from we're always going from the current position, but we want to go to close at this point. Current position to open. Now current position, when we open a door, if somebody calls the public open function, we set the current position to be its current position, because it could actually be in the middle of closing when an open trigger comes in from maybe an enemy approaching the door, and then it starts lerping from there. It sets door opening to true, which will trigger our loop in here, and then it plays the audio sound effect for the door opening. Same with the door closing, and then unlock will actually change the isLocked variable to false. So if the door is set to be locked by default, then nothing is going to happen, not even on a trigger, until the unlocked function is called. So in the player script, we can show you how the player can unlock a door. If a player walks into a key, the key has a reference to a door. So when you place a key in the scene, which I did here, so here's one of my keys, I've attached a door. I've actually selected door 2, which is my bigger door, it's this door here, to be the door that this key is going to work on, and I've set this door to be locked. So when you do that, I've an array list of door keys, and basically we grab the instance ID, which is the unique ID of that door, and save it there. Then when you collide with a door, if the door is locked, we check to see if we have a key. So what we do is we check to see if the index of the door we're walking in. So this basically, it says, hey, do we have this number in this array? If we do, we'll get back the index of that. We'll get the position. If we don't, it'll return -1. So if it doesn't return -1, we have that key, which means the key was found and we can unlock the door. Else, key was not found and then we don't unlock the door. And if the door isn't locked, then we can just open it. So that's how the door opening closing logic works. So now I'll go to one of probably the more interesting bits, is the enemies, and that should be almost the end. So the enemies are really interesting. I did a lot of work to the enemies. So the enemies have two modes. They have a follow mode and an overwatch mode. These are again built on top of code sourced from that Moodle example. Let me just go into enemy controller. So I've got this enum, we've got enemy moves, they're either overwatch or follow. So overwatch means they won't actually walk anywhere and they'll just shoot. So you can see here inside update, if the enemy type is overwatch, it'll run the overwatch code, else it'll run the follow code. So before anything here happens, we check if the player is killed. And if the player is killed, then everything's disabled. And this doesn't overly matter because we're going to load in, if the player's killed, we're going to load into our lose screen. But this just turns off the enemies if the player is killed. We're also updating the health text on which is this kind of like little UI that appears over their head, so that the player can see how much damage they've dealt to that enemy and how much is left. In Overwatch, we call the shoot logic function and we say if the player is within the chasing distance, which is also used in follow, then we should look at the the player. So the player knows that they're at a certain distance, that they're not going to come to them because it's Overwatch, but they're looking at them, they're targeting them. Let's get a bit closer, then the shoot logic kicks in. So if I look at the shoot logic down here, if we're within the distance of the shooting distance and the player is visible, then they will actually start shooting at the shooting interval range. So this is basically saying, you know, we can set an amount of time between each shot is fired. We can define that in the enemy script, and they'll start shooting at us. But I also added to this here the player visible, which I do a ray cast. Let me see if I can find where I do check if player is visible. So I do a physics ray cast, and if we hit a barrier, then we assume the player is not visible, and we disable a laser. I've got a laser. I have a laser line renderer effect, so it's like a laser eye effect, a sight. I disable that. If it's not hitting a barrier, then we are telling it to look at the player, and we set this boolean player visible as true, which means they can fire upon us if we're close enough, and the laser is enabled. Okay, almost done here. I added in an animator, added in animations from Mixamo. On kill, I've a couple of different death sounds. I have different sound effects, again sourced from Freesound, and I will play a random one of those when the enemy is killed. The health text is set to 0. The component capsule collider is disabled, everything's disabled, and I trigger my animator to the die trigger, and I have a death animation where they fall on the ground, which you saw while playing. And I also update my objective manager, and this is probably the second last thing I'm going to show you. So the objective manager is fairly simple. I wanted to track 6 different things in the game, so this objective manager takes in reference to 6 different text UI objects, which we're going to update. When we initialize it, we grab the initial text, which is whatever we set in the inspector, and save it as the message. And then on the update, we reapply that message, plus we check to see if the player has successfully stole the key. We see how many enemies have they killed versus the total number of enemies in the scene, how much ammo have they collected versus total ammo in the scene, health collected versus total health in the scene, if they've killed a bug, and if they've killed a drone. And if they succeed in any of these, we update the color to this unlocked color, which basically takes the initial color of one of our text objects, which has a transparent value, and we set it to fully opaque, so that you can see the object clearly, so it brightens it up so you can see the objective is selected. So then the last thing, and this I promise is the last thing, is the level manager. So this is quite simple. We've got a couple of functions here. We've got a quit game, which we'll call application quit. We'll quit out of the application. We've got a menu, lose, win, and restart game, and this will load the different scenes that we want to load, be it the main game, the win scene, the lose scene, or the menu scene, which you saw there in the game. So I'm just going to quickly check the brief to make sure I'm not forgetting anything. Oh yeah, one last thing to show in the brief, which is I have successfully uploaded the game to itch.io, and this will be a link to this will be included in the I'll reload this in the submission. So I click play so you can see the game very quickly here. So this is our start screen. We can hit proceed, and we load it into the game running in WebGL, and we can pick up objects, we can run around, and we can shoot at enemies, and that's that. So I'm going to close out of this, reload that, so it's going to stop playing, and that's pretty much it. Okay, thank you very much, and that is the screencast.